All right, inductor series with an inductance of 9 henries and a resistance of 15 ohms connected to a 60-volt battery was initial rate of current in the system. Okay, so now we go get our pen and we sit there. We start off by looking at the circuit. We don't do massive amounts of thinking right away. We just do general thinking right away. So this is what my circuit looks like according to the instructions. It's 60 volts. Probably right to put a switch on here, but I'm not going to bother. The ohms. And I've got 60 volt battery. I've got a 9 Henry inductor. Okay, so now I take a look at this and go, okay, so what happens? Inductor's the old man on the lawn. Do not want to change. So the moment the switch is thrown, the inductor says, nope, not going to let you have current. And so initially there'd be nothing happening. After a very long time, the inductor gets used to having current, and therefore the inductor would do nothing, would act like a wire at the end of the day. So those are the two extremes on the two ends. The maximum amount of current would be at the end, the minimum amount of current at the very beginning. So initially this thing acts, this inductor right here acts like a battery pointed the other way, stopping it. So what's initial increase in, what is initial rate of increase of current in the circuit? Initial rate of increase in the current in the circuit. All right. And then the second question, 4b, which is what is the rate which the current is changing at t equals 10 seconds? Okay. So initially my current is at 0. How do I know that? Because this thing is stopping it. Okay. But it asks the initial rate. That's di dt, right? So I need to think about it in terms of what is I so that I can take the derivative. And so I look and go, aha, it's one of these where I equals I max. Now, initially we're at 0 and it's going to increase, correct? So if the current's going to increase, I need to use the increasing formula. The increasing formula, I believe, looks like this. 1 minus e to the negative t tau. And I often forget which one it is, and I don't want to go back and use Kirchhoff's law and derive this using differential equation. So I look at this and go, wait a second. When this is 0 down here, this whole thing, when this is 0 for time, this whole thing becomes 0. E to 0 is 1, 1 minus 1 is 0, so this must be the increasing formula, right? The other one's the not increasing formula. All right, so I need to figure out what I max is. I go back to my thinking. I go at the very end. I'm going to have my maximum current. This thing is going to be doing nothing. So therefore, I go V equals IR. My voltage is going to remain 60. My current, I don't know, but my resistance is 15, and this thing's doing nothing at the end. So therefore, my current would be 4 amps. And so my new formula becomes I equals 4, 1 minus E, negative t over, oh, I need my time constant. Time constants for LR circuits is L over R. Man, I hope I'm right. Hey, never know. Yeah, I'm right, because it doesn't make sense to me. That's why. All right, good. Okay, so time constant L is 9, R is 15. So my time constant is going to be 9 divided by 15, which I just picked up my calculator by putting it back down because that's ridiculous. It's 0.6 seconds. All right, so my time constant is 0.6 seconds. So I'm going to put a 0.6 down here, boom, and I'm going to put parentheses on the end of it. All right, so this is my I equation, correct? I'm going to blow it up so that it's easier to deal with. By the way, 0.6 on the bottom becomes 5/3 or 1.33 on the top. I'm going to go ahead and do that. Switch it out so it's just multiplied rather than divided by. So this becomes 1.67-ish t. Okay, so that's my equation. I want to know di dt, right? I want to know the change, and so I go di dt equals, this falls out, and I get negative 4 e to the negative 1.67 t times, this is not just a t, so I have to tack on a negative 1.67. Okay, and so then di dt would be equal to negative 4 times negative 1.67. So I'm putting that in the calculator. That's 6.666. Okay. E to the negative 1.67t. All right. And so the IDT, in this case, this whole thing becomes 0, which makes e to the 0, 1, which means my current is going to shoot up at 0.66 or 67. Let's go and make 67 amps per second. Now, I suspect you got this wrong, so I'm going to point out what's going on here. Because initially we're thinking, wait a second, the thing stops it, but the thing can't stop it. Ultimately, all it's going to do is resist the change. Remember, when you normally try the circuit, it's just basically 4 amps. It's 4 amps instantly. This thing is resisting. It's saying, hey, you can only go up 6.67 amps per second. And you're like, okay, that means in 1 second it's got more current than we started with. But keep in mind, it's going to continue to resist it. Okay, so it's not going to be 6.67 for a full second. It's going to be less than that because obviously it's not going to go past 4 amps. Does that make sense? Sort of sense? Okay. Second thing is this. Let's ask the question at B, which is what I really got asked. So let's do B. Okay, so that's A. All of that was just doing A. I didn't even do B. Here's B. B, I'm going to use the same form. The IDT hasn't changed at all, so I'm going to do IDT. Now, I would anticipate there's going to be very little increase. Why? Because the current is not going to be large. If you solve this equation for current, you're going to get 0 current. So at time equals 0, you have 0 amps, when normally you'd have a full set of amps. The rate it's increasing, the rate the inductor is allowing to increase is 6.67 amps per second. By the way, that increase is going to decrease because it's never going to get past 4 amps. What is it at 10 seconds? It should be really, really small. Let's check it out. We use the same formula I just invented over here, 666, e to the negative 1.67t. Again, we already developed what dIdt is. So I'm going to go ahead and put in 10 up there. So I get negative 1.67 times 10. I'm going to e to that. And I get 5.588 times 10 to the negative 8th. Times 6.6667, boom. And I get my dIdt is ridiculously small, and that is 3.73 times 10 to the negative 7 amps per second. So at this point, so if I was going to graph the change, it looks like this, where we're approaching 4 amps. Okay, this is time. Initially, there's a massive increase, but it's going to flatten out. Okay, and again, the reason why is this thing tries to stop it altogether. It says, no, no current for you. It builds current inside this wire by letting the current change, but more slowly than it should be, which would be darn close to instantaneous. I hope that makes sense. I hope that's a good problem for you. It is a weird problem because it asks dIdt, not just I. Normally, these problems ask for I. Okay? If it's just asking current, we'd be using this equation for time equals 0, right? And we'd get 0 amps. We use this equation again for time equals 10. I imagine you're going to get darn close. In fact, I can predict that you would get so close to 4 amps, your calculator couldn't tell the difference, right? Because it would be very similar to this number right here, right? Because remember, e to the is pretty much going to give you the same answer. So the difference is going to be by a magnitude about that much. Yeah, 4. You're subtracting 4 from that. Okay, so it's not going to be very small, right? That said, so that's the normal question would be how much current you have, and the current would be probably 0 amps and 3.9999 or 4 amps at 10 seconds. But so it asks dIdt, the graph ends up looking like this. The graph looks like this. Initially, there'd be a rather large, but it's almost an imaginary number. By half a second, this thing is going to be way lower than 6.67. So it's just because it's asymptotic, right? All right. All right, hopefully that makes enough sense so you can do the problem and not panic. Again, this is a slightly weird problem because it's asking for DI/dt, not I. You know it does that because it says in the problem, what is the initial rate of increase of the current? Now, what's the initial current? What's the initial rate of increase of the current in the circuit? Okay? All right.